Artificial intelligence has taken the world by storm over the past few years, and image generation is one of its most interesting contributions to the modern world. In this course, I'll introduce the fundamentals of AI-powered image generation, beginning with the pros and cons of generative AI, the history of image generation, the uses of AI in creative content generation, and generative AI models. Then, I'll explore generative AI methods, how generative AI is used to create content, components of a generative AI pipeline, and use cases for generative AI. Finally, I'll delve into popular generative AI frameworks and tools, ethical considerations of generative AI, and how AI influences art, the implications of generative AI, and the possible future of generative AI. In this video, I'm going to talk a little bit about artificial intelligence, AI specifically, in the context of image generation, as well as its significance. So what's actually happening when we use an AI image generator such as DALL-E is that we're creating images from scratch. And what's actually happening is we're utilizing trained artificial neural networks to create these images. These neural networks are just learning a sample of data, a statistical sample of data that we've used as our training set. And once we look at our statistical distribution for our training data, what's actually happening is that the neural network is going to create points, artificial points, I should say, within that training sample. So what these generators have the capacity of doing is creating original and realistic visuals based on textual input provided in some form of natural language. This is the essence of what generative AI is that we can actually take some text, in this case it's English or whatever language we'd like, and then ask it to generate some images. Now, here's a good example here of what a generated image could look like. So what I have here is just a picture of a house on a beach. I generated this with a simple text prompt that I gave to DALL-E, and in a matter of seconds it was able to create this house on the beach, and that's what we're seeing here right now. Now, there's also some image generations that we have to look into, right? So an AI image generator has what's known as a machine learning principle behind it. Now, what we're using here are machine learning algorithms that can learn from these large data sets. In this case, it'll be images. And what we're going to do is then just allow to create these new images that are similar in style and content to the original data set. And the way the machine learning algorithm is working is that it's just looking at a numerical representation of these images so that it can actually generate the images for us. And what we're actually doing is we're providing an interface that's generated from some type of input. It's usually text. There can be times where we can use voice to generate some images, and so that'll help us with that. Certain large language models can now support voice to images. And what we're going to do with our AI image in our generating stage, we need to start with our training stage. So AI image generators, they're just trained on massive amounts of data. And this comprises about large data sets of images particularly, and they have all sorts of different resolutions and content inside of them. Now, what we're doing within the training process is we're going to learn the different aspects and characteristics of our data sets, and we're going to represent them numerically. So even though we see them as, a house on a beach, what's actually happening is that the algorithm is transforming that into a matrix of numbers, a sequence of numbers, so that it can understand it. And what's going to happen is they become capable of generating new images for us. And there are some popular AI image generation methods that we should look into. One of them is the neural style transfer, and there is the generative adversarial networks. These are the GANs that are used right now. And then there's also diffusion models. And what we're doing here, if we think about the generative adversarial network, is we're employing a duo of neural networks to train to produce realistic images that resemble the ones in the training set. So we'll have two pieces in a GAN, a generator and what's called a discriminator, and they have an adversarial relationship with each other. So they're trying to basically trick each other and then get better over time. And so that's the idea of what a generative adversarial network is. What you'll also notice is that there's a neural transfer technique, and what we're doing here is we're just enabling the imposition of one image's style onto another. And then there's the diffusion model, And what they're doing here is they're generating images through a process that simulates the diffusion of particles, progressively transforming the noise into what's known as structured images. And these are just some of the popular AI generation methods. In a few years, we'll probably have some more as we continue to do R&D on these methods. So what are some of the key activities for our AI image generators with these methods? Well, the first thing that we want to do is we obviously have content creation. We can enhance articles or social media content with these engaging images. But we also have creative projects where I can use AI generated images as some type of inspiration or starting points for any type of artistic endeavor that I may have. And then there's also educational purposes. I use this as well, where I can create visual aids or illustrations or some type of diagram that is going to help somebody understand a complicated topic. And finally, there's the design and marketing. We can generate graphics, logos, and visuals for things like promotional materials or branding. And that's just a little bit about what we can do with image generators and artificial intelligence. In this video, we're going to outline the various pros and cons of using generative AI image generation. So, what are some of the pros for the AI generated content for images? Well, one obviously is the time savings, right? I can create content much faster with the use of an AI image generator than I can with just on my own. So it can produce an article in minutes, for example. It could also produce an image in seconds. It would take a human much longer to do all of that image generation ourselves by hand. So this is actually really useful because what's actually happening here is that we have greater efficiency. The main issue with doing it by hand or having a person create an image or some type of content is that it's not very scalable. We need a person. As we need to create more and more of this content, we need to now pay more people to do it. It becomes, you have to balance out the cost and the benefits of actually trying to turn up the production value of your images. Now, with the scalability, what you're actually seeing is that the AI image can generate a large number of images very quickly and efficiently, and they're great for creating large volumes of visual content for things like marketing, advertising, education, all sorts of purposes for this. This also brings me to my next idea, is that cost is a major advantage here. What we're doing here is let's say if I'm hiring artists, what's actually happening is that they're going to cost a few $100s per project. And depending on what the images are, they're also not necessarily free for those writing tools or imaging tools that they need to use. So these considerations, right, you can almost see that an AI generated content might be better suited for simpler content and that it actually is much better for the cost. It's cheaper to generate these images this way. And this also leads to enhanced creativity, because what you'll see with AI image generators is that they can actually inspire creativity by generating unique and unexpected images that human designers may not have thought of. And what you're going to see is that this is going to lead to new and innovative design ideas that can set a brand or product apart from the competition. Another thing that's very useful is consistency. These AI image generators can create images that are consistent in style and quality, and they can help establish a brand's visual identity and improve things like brand recognition. And they're also accessible. This accessibility here can make visual content creation more accessible to people who may not have design or artistic skills. And anyone can actually hop on and to look at DALL-E, for example, on OpenAI and generate some images that way. And what you're going to see is that this is going to help the creative process and give more people the opportunity to create high quality images where they couldn't do that before. Now, there are several cons that I want to discuss, and some of them is that there is varying quality of the images, right? So we know that AI systems, they can sometimes struggle with producing images free from things like imperfections or artifacts you'll find in the real world, right? Now, the inability to generate these flawless human faces, for example, and you can actually look at this right now as an example for an image generator. If you go to thispersondoesnotexist.com, you'll actually see pictures of human faces that aren't real, that are actually generated with an AI. So those are generated human images, faces of humans online. and you can actually look at them. And if you actually refresh the page each time you go to this website, you'll start to see that there are some artifacts there that aren't 100% accurate. And so this actually is going to vary in quality with our images. And so this is something that would require a more of an iterative approach when using an AI image generator. Another thing is that authenticity. Now, this is where we want to make sure that we're not violating any type of plagiarism when it comes to this, right? So what's actually happening, right? AI is relying on the training data. And what will happen is those training data is actually created by a human being or an artist. So what AI is going to look at all of those, could be copyrighted images or some other artist created them, and they're going to try and mimic those images as best they can. Now, sometimes they might mimic them a little too closely. And this is where we get ideas of plagiarism. And so this is actually an interesting problem that's coming more, that's centered around legislation on how we can use AI image generation. So that's the idea, is that, are we opening ourselves up to legal action by using these kind of AI image generation? Are we plagiarizing in the sense, if this model is actually spitting out some images? Now, there are some cons to it. For example, there's copyright and ownership, like I was talking about, right? If the deployment of AI generated images, this is one of the main ethical questions that we're trying to figure out. What do we do here when we are generating images that resemble copyrighted materials? In fact, just in January of 2023, there are artists filing lawsuits against top companies in the AI art generation space because they are using their images, their art, as part of their training data. And so this is going to lead to all sorts of things, such as devaluing our content. So this is where, almost in a sense, that if we start to generate as many images as possible, as quickly as possible, in seconds, well, then all of a sudden the images almost lose their value, in the sense, because they're very cheap to produce. Anyone can make anything in seconds. So exactly what does this do? And so this is the idea of using image generation. Is actually going to change a little bit of how we consume images and what it actually means to own something. A few more cons here is that some people will say that there is a lack of creativity and personality. Even though it does help you generate new images, there's still a little bit where creative content is kind of missing. You'll notice that you will require some human editing in the images to some point. Sometimes they can't generate new images. Sometimes it's too complicated. Sometimes it's just nonsensical, the images that are generated. They don't really make a lot of sense based on the text inputs that you have. But there are some challenges here as well when we try to represent humans this way. So if we actually look at images, or almost if you can read text, for example, I know we're talking about images, but if you read text, you can almost tell that it's not written by a person. You can almost see that it's written by AI. If you can also see as well that, same thing with images, you can almost tell that it's like too cartoony, if that makes sense. It doesn't necessarily it's not 100% photorealistic. So you see that there's some lack of personality in the images that are generated, and especially when we try to represent human faces. And so there's all sorts of things right now that we're trying to work on to try and generate pictures of human faces. And there are certain websites that are trying to do that right now. Again, if you go to thispersondoesnotexist.com, you'll see that there are some AI generated human images that you can actually see every time you refresh the page. A few more cons here, and this is really important now, is the idea of deepfakes and misinformation. So what we're actually doing here, we're giving a tool so that people can create deceptive media, which is already a problem as it is without AI. So you almost have these image generators creating deepfakes where they look realistic, but they depict events that never really occurred. And if you couple that with someone's deepfake video, you can also mimic their voice, which is kind of scary as well. So I can have some political leader, for example, saying something that isn't true with their voice, and you'd never be able to tell. It becomes very hard to detect. And this is a major detection challenge because deepfakes are becoming increasingly sophisticated, and it's very difficult to distinguish them from authentic content. There's also image dependencies and fine-tuning that takes a long time to do. So fine-tuning is the idea of achieving desired level of detail and realism. Means that we're going to have to take our data and our model parameters and basically fine-tune them with new data sets. And this is going to take a very long time, and it's very time-consuming and costly. There's a lot of money involved in this. And what we're actually starting to see here is in the medical field, where you'll have AI-generated images used for diagnosis, and they need to have like a very high precision. And so this is the idea of using the image dependencies and fine-tuning step in the medical profession, is that they'll constantly be feeding it new data so that the parameters are fine-tuned for what they're trying to do. And that is, in this case, having high precision. So that's a little bit on some of the cons and pros of using AI image generation. In this video, I'm going to discuss the historical evolution of image generation techniques. So AI image generators can really make a lot of images in just seconds, right? But exactly what is happening here is that we are using a very large amount of training data, and training is a very complicated problem that we have to solve. So right now, what we have today is we have images that are based on text descriptions, and then we type in something and we provide it to the artificial intelligence model here, the GAN in this case, and it generates an image. But what actually is happening is that we have to train this data set before we even get this far. And training is just a very expensive, time-intensive process. So what we want to do now is just sort of talk about how did we get to this point? Where did it all start? Well, it all started back in the 1960s. There were advancements of the studies of visual image processing. There were two scientists that were working out how visual cortices contain neurons that respond to small regions of the visual field. And this is back then. They, provided the eyes are not moving, they said that the region of visual space within which visual stimuli affect the firing of a single neuron is known as its receptive field. And so what they figured out was, they said there's two basic visual cell types in a brain. They said that there's simple cells where their output is maximized, and there's complex cells which have larger receptive fields, and they can figure from those two cells, that's basically how our images are recognized in an animal's brain, especially our brain. So it all actually started from neuroscience at that time. And we fast forward just to 20 years later, where computing starts to become a thing, and we see that the images and pictures, we can actually start using machine learning, right? So digital image processing started in the early 1960s. We had some basic algorithms that were the main tools used for altering and enhancing images. And then later on in the 80s, we had some machine learning models integrated with what's known as photo generation. And these models added to the intelligence and guided the process with data-driven techniques. And that's basically how it started. We looked at something that was in nature and then built a computer model around it, trying to mimic this thing. In this case, the nature were the two types of cells that are in the brain. And, obviously we didn't have the computing power to start dealing with very powerful images, but the theoretical framework was there. Even in the late 80s, throughout the 90s, we had some of these tools available for us. But the model was there, but the computing power wasn't. So we actually started to see around in the 2010s that there was a rise in high quality editing. And so what we started noticing is that once we have this high rise in high quality editing, we started looking at, hey, is this possible that now that we have the computing power, can we go ahead and do rise of style of transferring GANs later in the 2010s? And again, we had the models for GANs for quite a while before we actually made it accessible for everyone with the tools that we have, such as a computer. We just didn't have the hardware necessarily for it. So the ability of AI to generate lifelike images, has a lot of implications, but it all started basically as the computing power started to increase. We started to see that there are high quality editing tools within our computers, and then we had the rise of style of transferring GANs, where we can actually hey, can we actually teach a machine to do the same thing that we're doing with these tools that we have? And so then we had all sorts of automation, accessibility, and ethical concerns. This is where we are now in the early 2020s, where we have things like augmented reality and 3D modeling. And then these developments also sparked discussions about the ethics and regulation for our AI and photo generation. We can generate any photo of anything, but the question is, should we be able to? That's a problem that we're trying to solve right now. And so then we have the deep learning and convolutional neural networks, or CNNs. So now we've got things like neocognitron. So this is the origin of what's known as the convolutional neural network. And this was introduced by a scientist around in the 1980s. And what's actually happening here is that we are looking at two types of layers. Like if you think of a convolutional neural network, we've got basically two pieces to it. We have what's known as a convolutional layer and a downsampling layer. And all this means is that a convolutional layer will contain neurons whose receptive fields cover a patch of the previous layer. And what you're also going to see that there's downsampling layers contain units whose receptive fields cover patches of previous convolutional layers. And so if we alternate between these two layers in a neural network, we get all sorts of interesting things. And this is where in the 80s, where we've created this first convolutional neural network approach. And what this did was it transformed the game around in the 2010s, and these technologies introduced concepts like things like style transfer and generative adversarial networks, all kind of started there, because what you'll notice, especially in image generation, is that they're kind of following the CNN approach, right? We have the generator and the discriminator, and they're both using the CNN kind of model to sort of make this either a great generator and a discriminator, and kind of trying to compete with each other. So both the generator and the discriminator are based on the CNNs. So what I'll also add here is that, there are some artistic issues that we're seeing. So AI-assisted image generation goes pretty mainstream. And by mainstream is that pretty much anybody with a phone now can just type something into a text box and have an image. And this enabled a wide range of creative possibilities. We have things like AI-assisted images to creating popular GIFs in various styles in just a matter of seconds, where before that could have taken a long time. And this is now, we're at the debate stage over what art is and what does that mean exactly. Like if an AI is able to generate art, how is that a thing, right? So what does that necessarily mean for the artist that originally created the AI? Who owns it? Is it the company that created the AI owns the art, or is it the person that created the text prompt? Is it the artist that originally created the training data that the AI was trained on? It becomes a very strange legal and legislative issue. And so that's something that we're trying to figure out today. And this is the idea of the artistic issues and the image generation, as well as just some brief history of what is happening with our image generators. In this video, I'm going to discuss the role of AI in creative content generation. So artificial intelligence is a really cutting-edge field of computer science, and it aims to create systems of simulating human intelligence and really just problem-solving capabilities. One thing the AI content is really good with providing is control. AI's influence in content creation is really great when it comes to the control of what content that we get to create, and it helps with increased of productivity, including productivity that could be from text or from visuals that you're trying to generate, because you're able to generate them in just seconds and you have this control over what image and text you have. It actually is a great opportunity to use AI in our creative content writing or image generation. And we have unlimited imagination, limitless imagination. You can use AI image generators to create imagery of anything in any style you desire. And it really just becomes up to you what you want to create, and you can create it in seconds. There's also some uniqueness as well that we can create, as every single image you generate is going to be created from scratch. So you can be assured that every image is going to be different, so that you're not necessarily going to be generating the same image as I would be generating using the same prompt and tool. So that's really useful. There are some more opportunities that I want to give into, and that is with image generation. So in the realm of image generation, AI has made remarkable strides with tools like Midjourney and DALL-E. And there's also ones that are coming out now that are doing video generation. So Sora from OpenAI is one that comes to mind. So we can actually generate video content, and there's AI-powered tools that'll enable the video creation and the editing suite that we'd like. And it all happens from just a simple text-based prompt that we provide. It's also can be extended to audio creation. AI's role in audio content creation is significant. We have things like text-to-speech technology, which is powered by AI, and it can convert written content into natural-sounding spoken words. There's also other things that we want with the generating of new content. We can use AI to generate new content with, for example, if you've seen an advertisement that can actually be generated. I believe Coca-Cola has one, Pepsi has one, where we can actually use AI to actually generate some full-on ad campaigns through images. And we can also use something for text generation. So use this AI, such as ChatGPT or ChatGPT-4. It can produce human-like text in seconds. And this is very useful for content creators because AI can assist in drafting articles, blog posts, creative writing pieces, and really just about anything. It can help generate what's known as marketing copies and product descriptions that resonate with a target audience. There's some more content marketing that I'd like to sort of delve into here, and that's the near instant task generation. We can actually do this in seconds. You'll have AI generated images for social media, and there's also things that we can modify the influencers to suit an audience. So if you have an image for a social media page and you're trying to modify your page, your social media page, using an image crafted to a certain audience, you can do that as well. And it can be even extended, believe it or not, to understand natural history and biology. So we can look at artificial natural history is what it's called, where we can look at creatures and plants that are kind of creating them from data that we've collected. And, you can look at never before seen features that require a new set of biological classifications. So it helps us gain a better understanding of natural history. So imagine if we have some type of archaeological data where we're trying to recreate a creature or a plant that we've seen. We can use AI to generate those images of those creatures and plants, and it permits us to gain a better understanding of our natural history. It can also be used in architecture and design. So we can aid in the design of homes and buildings, for example. So if you've got an architect that's trying to come up with a design for a home or a building, using the image generation tools that can help you come up with some ideas. It can facilitate better and more creative designs and really just assess flaws and architectural weaknesses in the actual design that you're trying to make and help you design a better home or a building. And here's just a brief example of a generated image. This was done with DALL-E from OpenAI. And just with a simple text prompt, I was able to generate an image of a house on a beach. And this just, as you can see, it's very detailed. It has exactly what you'd ask for, sunset, everything's really there. And that can just be done with anything. If you look closely at this image, it's almost photorealistic of what's capable. So it's very hard for you to tell that this was AI image generated. And so now this is becoming more and more photorealistic as we get new versions of these image generators. A couple things I also want to add, and there are some other ways that AI content generation will aid in creativity. There's style enhancement or style modification. I get to create a unique and compelling writing style, and AI can play a crucial role in defining it by analyzing, like, for example, data sets of diverse writing styles. I can ask an AI model to mimic a particular tone or pace or an overall style alignment in my writing. And I can also use AI to help me with my grammar. I know I struggle with this at times, and AI is very useful for this, where we have better identification of grammatical errors. I get to analyze written content. There's things where I can suggest corrections, and it can even enhance what's known as the sentence structure, so it's more coherent and able to be understood better. And we've got also the audience engagement is the final one. This is really important. When I create content, I'm obviously creating it for the preferences and expectations of a specific audience. And so I have to either understand the audience or figure out what words to use. Well, with AI, it can help me it knows what the audience is looking for, and it helps me craft my message and my content to that audience. So if I'm writing a children's story, it's able to write a children's story for me. And there's so many ways that we can actually use this AI tool to assess the content and the audience engagement. And it really is, there's so many possibilities there. So when I use the AI and I give it as much information on the audience that I'm trying to present to, it's able to better understand that the content is going to align seamlessly with the audience's unique interests and preferences. And I can do this on a person-to-person in an application, for example, or I can do this very broad for a group of people. So that's a little bit on how we can use AI to generate images in a creative solution. In this video, I'm going to be discussing some popular generative AI models. They include things like variational autoencoders, VAEs, generative adversarial networks, or GANs, diffusion models, transformers, and neural radiance fields, or NeRFs. So let's get started with variational autoencoders. Some of the top AI models that we use for generating new data use a few different techniques and approaches to generate this data. So there are some key features that are specific to variational autoencoders. VAEs were developed around 2014, and they follow what's known as the encoder-decoder architecture to generate new data. And we use them for image and video generation. So typically what you'll see them do is generate synthetic faces or synthetic images, or generate some text, that kind of thing, or video, for example, but not text. Another one that's very powerful is the generative adversarial networks. And what these use is a generator and discriminator to generate new data, and they're often used in things like video game development for creating realistic game characters, which is kind of interesting. But not only that, we can actually use a generative adversarial network to do all sorts of things, such as generate new images, videos, and text. And the diffusion model works in a similar way. They add and then remove noise to generate quality images, and they usually are very good at high quality image generation. Their images are actually near photorealistic of natural scenes, like anything like that. Now, the idea is that this model came in about 2015 from Stanford, and we used things known as reverse entropy and noise. This is where we end up with things like stable diffusion and diffusion. They're usually used interchangeably. What we'll notice is that what we're trying to do here is just add noise and remove noise to the image. And what this is basically just a probabilistic generative model that makes this use of noise injections and learnable transformations to generate realistic images from what we call random noise vectors. And then the transformers were developed in 2017 by a team at Google, and this is used for improving language translation. So we have something known as sequential data processing as one application, but they're also used for things like text summarization and machine translation as well. But what you'll also see them with text summarization, but they're actually not just great with text and machine translation, but they're very good at image generation. So we can actually create entity recognition for identifying people, places, and things within the images, as well as creating new images as well. Now, neural radiance fields are more recent than the transformers. They were developed in 2020. And what these do is they capture 3D scene creation and 3D representations of things like light fields and into a neural network. You'll see that the first implementations that we have are kind of slow, and they took several days to capture this kind of 3D imagery. But lately, in just 2022, if you're familiar with the company NVIDIA that works with GPUs, they found a way to generate a new model in about 30 seconds. And the idea is that they're using what's known as a neural representation of the tools. Now, they're very computationally expensive. And so what we're actually bottlenecked with this model, this may be the future of image gen or data generation, is using neural radiance fields. But what you're seeing now is that the hardware needs to catch up. So companies like NVIDIA, AMD, Intel, they have to now make the hardware that would potentially help us study these kind of models. Right now, they're just a little bit different, a little bit difficult for us to actually experiment with the current hardware that's supported. And finally, we have a few different considerations for selecting a model. So now that I've talked to you about the few different ones, how do we know which model to pick for our problem set? Well, first, you always want to ask yourself the question, what problem are you trying to solve? You want to choose a model that is known to work well for the specific task, and you want to use something like transformers for language tasks, and you could use something like NeRFs for 3D scenes, for example. There's also the question of quality. What quality is required? For example, GANs are better for clear and detailed images, but you'll also notice that variational autoencoders are really good for smoother results from the images. And sometimes we just need to understand how much control is needed in the model. So variational autoencoders are better than GANs in this respect because you can have more control over the results or a better understanding of how the model works. But with the generative adversarial network, you have a generator and discriminator working in pair, and it becomes a bit of a black box for us to understand how the data is generated. And so there's less control in that kind of model. But then the idea is, how much data do you have and what's the quality? This all comes down to whether or not we can use whichever technique. So the amount and quality of our data, we could have things like transformers need lots of good data to work well, while variational autoencoders work better with less data, if you can believe that. You could also have some type of computational resources that are needed. So you'll have things like NeRFs and large transformers both need a lot of compute power, and it's actually more expensive. So it's something you want to keep in mind is the cost of actually training these models is directly related to the computational resources as well. How easy is it to train this model? Well, GANs are pretty difficult to train, but you'll find that variational autoencoders and transformers are actually much easier. So that's a little bit about the different models in the space of generative adversarial networks and variational autoencoders, and really just anything that can generate any data, including images, videos, text, all sorts of things. And also just how to pick a model when we're trying to solve a problem. In this video, I'm going to outline some of the methods that are used in AI-powered image generation specifically. So what I'm going to talk about first of all is the generative adversarial network. Now, these are commonly referred to as GANs. You'll see them in the literature. And what they are is just a class of machine learning algorithm that harness the power of two neural networks. One neural network is known as the generator, and the other one is known as the discriminator. Now I want to understand in the generative adversarial network is the term adversarial. This arises from the concept that says that these two networks, the generator and the discriminator, are pitted against each other in what's known as, you could think of it as a zero-sum game. They're basically trying to beat each other. But the difference is that when the generator can generate new data that might fool the discriminator, hence the term discriminator, the generator will tell it how it fooled it, and the discriminator will fix itself. And then what will happen is that the discriminator will beat the generator and then tell the generator how it's losing, and the generator will then fix itself as well until it's able to beat the discriminator. And this kind of adversarial back and forth between these two will happen. And this is how we know eventually, if we do this millions of times, we're going to get these two submodels being very, very good generating new data, but also discriminating between the real data and the fake data. And that is really the concept of this whole generative adversarial network. So you can almost think of this as it's taken from a concept in mathematics known as game theory. Now, this is known as the adversarial game. The adversarial nature of GANs is derived from this concept, and what we're trying to do is get the generator to produce fake samples that are indistinguishable from the real training data that we supplied it. Now, the discriminator is going to accurately identify whether this sample is coming from the generator so that it's fake, or it's coming from the training data so that it's real. What's going to happen is this ongoing contest is going to make sure that we have this concept of continuously learning and improving. So just going this back and forth of trying to figure out how the generator is fooling the discriminator, and then the discriminator is going to get better, and then it's eventually going to be able to understand how to beat the generator, and then the generator is going to have to improve itself. That's the idea. The game is really never ending. So when the discriminator gets better at identifying fakes, then what's going to happen is it's going to tell the generator how it's identifying the fakes, and then the generator is going to try and do a little bit better. It's going to try and generate better fakes. until the discriminator can't tell the difference anymore. And the idea then, we can branch this off and look at something different with the variational autoencoders. Now, how do they work? Well, what you'll notice with variational autoencoders and just general autoencoders, what we're doing is known as a reconstruction loss function to tune the neural networks using this mathematical concept known as gradient descent. Really, what gradient descent really is just a mathematical process or function that we are trying to use to minimize the error or the loss in this case. Now, we're using a specific type of loss function with the variational autoencoder, and it's called a reconstruction loss. Now, the optimization algorithm is going to adjust the weights of our neural networks connections in response to this feedback about this loss function. So if my loss function gets a little bit higher, what I'm going to do is I'm going to readjust the weights in my system, in my neural network, so that it is able to minimize the loss the next time it goes around. And so you do this constant retraining. So the algorithm is going to reward the neural network configurations with the lower loss functions since they're more similar. But you'll notice that with a higher loss function, we're going to penalize those ones. And then this training process is going to let the autoencoder capture this underlying structure of the training data. And we're going to use it to model this thing inside of our neural network. Now, understanding the variational autoencoders also branches out to the idea of probabilistic field represents input data. Now, what does this mean? Well, when I'm talking about a probabilistic field represents input data, I'm really just referencing the ideas that we are going to take our input data in what's known as latent space, and this is where we end up having to understand mathematics inside of this tool. It becomes very complicated. So in contrast, we're going to use a variational autoencoder that uses a probabilistic field that represents this input data rather than actual input data. Think of it as a statistical distribution of the mean and variance of the data rather than the data itself. It's a little complicated here to sort of explain what's going on, but understand that we're going to be using probabilities about the data that we're feeding it rather than the actual entry points to the data. It gets a little strange here. But because in a classic autoencoder, what we're really dealing with is the input data as discrete points, and it's hard for us to work with this. And this is what we're going to do here inside of the variational autoencoder is we're using a special type of measure called the Kullback-Leibler divergence function. Now, this is known as the KL divergence function, and it represents the difference between what's known as the learned distribution and a predetermined statistical distribution. Again, this is where the theory behind what these variational autoencoders are very deep, and we can't really go into them a lot here in this slide, but understand that what we're dealing with here is probabilities and using a special type of function to sort of map out how those probabilities differ from a known statistical distribution. Diffusion models are a type of generative model in machine learning, and they create new data. And so what we're doing here with this new data is specifically on images or sounds. And what we're going to do is imitating the data they've been trained on. So they're very good imitators. They accomplish this by a process similar to diffusion, but they progressively add noise to the data, and then they learn how to reverse it to create new similar data. So I want you to try and think about concept of diffusion models of like a chef or a cook who learns to make dishes that taste exactly like the ones they've tried before. But what you'll notice is that the cook will taste a dish, usually look at the ingredients, and then we'll make a new dish that tastes very similar, slightly different. Diffusion models can generate data like images, but they're a lot like the ones they've been trained on, just like the chef is with the cooking. And so what we want to do with diffusion models is we want to look at the back and forth between data and noise. So look at the forward diffusion. If we add things like ingredients to a basic dish, in the stage, we called this forward diffusion. The model will start with an original piece of data, such as an image. Let's pretend it's an image. And they're going to add some random noise through a series of steps. And this is, again, getting to be a little bit more mathematical, but it's known as a Markov chain. And we use Gaussian noise, which is a common type of random noise to sort of add some random noise to a piece of information. And then finally, what we're going to do here is training, right? This is the concept of the chef understanding our tastes. So what we're doing here in the model, we're learning how the noise added during the forward diffusion will alter the data. And then what we're going to do is we're going to map out the journey from the original data to this noisy version. And what we're doing here is just mastering this journey so that when the model can effectively navigate backwards. Remember, this whole concept is not just adding noise to the data, but we're trying to undo the noise to get back to the original data. And this is the concept known as reverse diffusion. This would be the chef recreating the dish. Once we've known that the model is trained, what we want to do is we want to reverse the process. And we're going to take this noisy data, which could contain some aberrations in our image or it could contain anything, and we're going to remove the noise to get back to the original data. It's kind of like retracing the steps in our journey, but really in the opposite direction. But when I retrace the steps in this direction along the sequence of the Markov chain that I had, what will happen is that the model can produce new data that resembles the original. It's kind of fascinating. And this is where we get new data generation, making the data. Finally, the model can use what it learned in the reverse diffusion process to create new data. It starts with some random noise, which is just like a messy bunch of pixels, for example, in our image. And then it takes in a text prompt that guides the model in shaping the noise. And the text prompt is like an instruction manual for it, just like we do when we work with ChatGPT or any other large language model. It's the same kind of thing. And another thing that I want to touch on here is the natural language processing technique. So AI image generators understand text prompts. We usually give it a prompt for some type of text. And what this job to do is to translate this textual data into a language that a machine can understand. We call this language numerical representations or embeddings. And so what we'll have here is we want to convert this text into numbers or vectors or embeddings. And this conversion is done by the natural language processing model. And we use something known as, for example, the contrastive language image pre-training model. And this is used in image models like DALL-E. This is how we can type something in, it knows what we're trying to generate an image of, and then moves on to the next step. It's very good at capturing the meaning and the context of what I'm trying to give. And this is where we can have things like an example, such as a red apple on a tree, to an image generator. What's actually happening is that the natural language model will take the words, a red apple on a tree, encodes this text into a numerical format or an embedding, and it captures the various elements and the relationships between them. And this numerical representation acts as a navigational map for our image generation AI. There's also things such as the Neural Style Transfer, or NST. Now, this is a deep learning application that fuses the content of one image with the style of another image to create a brand new piece of art. And so what we want to do then is understand the visuals and the methods in this model. All it's doing is we're using a pre-trained network to analyze these visuals and employ additional methods and measures to borrow the style from one image and applying it to another. And what we have is this weird synthesis of in a brand new image that brings together desired features. Now, how this actually works is we start with these concepts known as neural layers. And these neural layers are going to contain all of the mechanics and the mathematics in this model. So it's basically just a neural network. And what we're going to do is then use this loss function, which could be a content loss function, a style loss function, or a total loss function. Those are usually the typical ones that we work with. Now, what we want to do in this content loss function is we want to retain the content of the original image. So it means that we want the generated images to have recognizable features of the original image. That's when I'd use a content loss. I'd have something like a style loss where I want to really focus on the style, such as the textures, the colors, and the patterns in the image. I'll have things like style loss measures the style differences, for example, or the patterns and textures. And what I'm trying to do with the NST here is attempt to match the textures and the patterns across the layers between the image that I fed it in the training model and the generated image. And there's optimization. And so what you'll notice here, as the optimization progresses, the generated image is going to take the content and style from different images. The end result is usually going to be a blend of the two images that I gave it, often bearing a striking resemblance to a piece of art. That's usually what ends up happening. So that's a little bit about image generation techniques with certain models, including how these models can take our text, transform it into an embedding, and feed it to one of the image generation techniques. In this video, I'm going to describe some of the various ways that we use generative AI to create content. So, how do AI image generators work? Let's see exactly what's going on underneath the hood. Well, AI image generators work by using machine learning algorithms to create brand new images. And we do this on a set of input parameters or conditions that we give it. And what you'll notice is that in order for our machine learning model or our AI image generator to be trained, we need a large data set of images that are representative of our data sets. So what we're going to do here, and this could include things like paintings, photographs to 3D models and game assets. What you'll notice is that the data set is going to be very diverse, and we want to represent all of the images that the AI image generator will generate. Remember, these things really follow this concept of monkey see, monkey do. Whatever you give it, it could potentially show up in the actual model that gets spit out. Okay, so let's move on to how these things are trained. Well, the AI image generator is going to be trained using these machine learning algorithms, and their whole concept is to learn from patterns and features inside of our data sets. And this is in training, these neural networks are going to identify and extract specific features from our images, and those specific features include things like shapes or textures or colors inside of those images. And then it all comes down to the training technique that we're going to be following. So if we look at models like DALL-E or Stable Diffusion or even Midjourney, they're trained using a combinations of the following techniques that I'm talking about. So we'll have something known as supervised learning. What this means is that the models are going to be trained on our large labeled data sets of image to text pairs. And sometimes what you'll notice is that we can scrape things like the image caption data from the internet and add that to our model. Each image is going to be paired with descriptive text caption. And what will happen is that we're going to provide this direct supervision for the model from those text captions so that it can learn the relationship between the textual input and the image output that we want to have with its visual features. Now, what we're going to notice is that the model is going to be optimized through gradient descent techniques to minimize our loss function or our error in generating the images. There's also something known as unsupervised learning. Now, these models apply methods like things like autoencoders and self-supervised learning on large unlabeled image datasets. What you'll notice is that with autoencoder, this will allow a model to reconstruct images through such as information bottleneck or teaching useful image feature representations, for example. There's also known as reinforcement learning. The models are fine-tuned using reinforcement learning from human feedback. We actually see this all the time in our everyday lives when we use a Netflix or YouTube video, for example, when we have that thumbs up, thumbs down rating system. What we're actually doing is we're providing feedback to the model so that it learns what we like and what we don't like. And this is kind of what also happens when we actually ask it to generate an image. If we use things like DALL-E or on OpenAI, when it generates an image, there's a little thumbs up or thumbs down button that we can give so that it can learn a little bit about what we like and what we don't like. What you'll notice is that the model is going to be rewarded for images that are rated highly by humans through this concept known as policy gradient reinforcement learning. And what this means is that it's just going to take our input and reward it if we have a positive input or not reward it if we have a negative input. And this provides direct feedback for the model so that it improves its text-to-image generation capability. There are some key steps inside of the training process that we want to first understand. The first part is data gathering. This is our very first step. It's actually kind of step zero if you think about it. What we're going to do here is we're going to compile a massive training data set, and it's going to contain tens of millions of image to text pairs. Now, these are gathered by scraping public sources like books and the internet. And what we're going to do is that have the image cover a wide range of visual concepts, while the text captions will describe what's actually in the image. Now, this diverse data teaches the model to associate the words and phrases with our visual representation. There's also something known as model evaluation. Before our training begins, what you'll notice is that researchers are going to test out different neural network architectures, find the optimal model design for an image generation tool. There's also known as model training. The chosen model architecture then undergoes extensive training on the massive to image text dataset. Now, this is just an iterative process where the model gradually improves at transforming text into corresponding images. This is the concept of our training process, and it occurs on powerful GPUs that are typically made by NVIDIA or Intel or AMD. And this is where we can take weeks or months of continuous processing to complete. And this is such a massive data set that is cycled repeatedly to refine the model's parameters over and over and over again. That's why it takes such a long time. And it's very expensive and a time-consuming process to do this. Now, AI image generators will generate brand new images. They're going to use things like input with the parameters that's provided. And these parameters can include things like style, color, texture, and shape. And these input parameters can be set by a user, or you can actually determine them by the AI image generators themselves. What you'll notice is that machine learning algorithms are going to produce content based on whatever we gave it in training. So although we're using the input parameters to generate a new image, the process is going to involve using these ML algorithms to combine the manipulated features that we used during our training set to create a brand new images as well as the input parameters that we gave it. Now, this process of generating a new image can be repeated multiple times, and it can actually be done in seconds in an iterative process. And each time you do it, you're going to have slightly different variations so that we can refine the image until it meets the desired specifications. This is something that you can try right now with the DALL-E tool on OpenAI or Google Gemini's large language model. You can actually ask it to generate images as well. And you can have this kind of recursive approach, this iterative approach to actually generating those images. Now, this is the concept of color vectorization. Now, color vectorization, or really we call this vector quantization, and specifically to generative adversarial networks, or GANs, this is going to revolutionize the way we create and manipulate digital images. Remember, GANs are just two neural networks, the generator and the discriminator. And all we're trying to do is get the generator to fool the discriminator. And because the discriminator is trying to differentiate between training data that's been supplied by us and fake data that's been generated by the generator. Now, they're going to work in tandem, but at the core of what we're doing here is we're going to have this vector quantization. Color vectorization is a crucial component of AI image generation. When we talk about graphics and computing, what we're really doing is we're taking a combination of red, green, and blue values. What we're vectorizing the colors allows computers to read them as sequences of numbers, and the sequences combined form images. Now, there are more realistic and vivid images that can be supplied based on these vectors, but vector quantization is going to help in creating more realistic and vivid images by allowing this generator to understand things like the colors in the given image or also the textures in a given image. It aids in reducing the computational complexity of our image generation, and it makes the process far more efficient, and we'll get more realistic and vivid images using this concept of vector quantization. Now, remember, all we're talking about with vector quantization here is breaking down things like our colors into a set of these discrete vectors, one for red, one for green, and one for blue. And we're going to have a far greater degree of control and detail when generating images this way. So that's a little bit on how we can actually use these training pipelines and training processes for a image generation AI. In this video, I'm going to outline the key components in creating an AI-powered image generation pipeline. So the first thing I want to discuss right now is our basic AI pipeline example that deals with model creation. After we create the model in model creation pipeline, we're going to move on to production. But first, let's get started with just getting started with our first model that we'll create. Well, when we create our first model, what we have to look at is look at the image data. This process is going to begin with the input data that you plan to use and train for our machine learning model. The data is typically a collection of examples with features that the model is going to learn from. The next thing is known as feature generation. What this step involves is transforming raw data into a set of features that can be used by the model. Now, these features are the attributes or the properties that the model is going to be using to make predictions. An example of a feature could be, well, it could be the what's actually in the image. It could actually be the size of the image. It could be its label. There could be some information that's attached to the image, metadata that could help it make a prediction. Those are the kind of things we're talking about. It gets a little abstract in feature generation when we're talking about images because there's a way that what the actual machine or the model that we're using is going to be able to identify certain features that we're not going to be able to understand as human beings, right? Because what's actually happening is we're taking an image and converting it into a numerical representation, and there are some features that are there that are just going to be understood by the model. And then what we're going to do is we're going to train our model. In this step, what we're doing here is we're taking the prepared features that are going to be used to train the machine learning model, and the model is going to learn from this training data by adjusting its parameters to make accurate predictions. Then there's the validation of our model. Now, after we've trained the model, we need to make sure that it's correct, and this is where the validation step comes in. It involves using a separate data set that's not seen by the model during training to evaluate its performance. Similar if I were to give a student a test to evaluate how he's learned the material, there's ways that we can do that. Now, this step is just help to check for issues like overfitting and to ensure the model generalizes well to new data. So what we're doing in this validation model step, just like I would with a student, is when I give a test to a student, I make sure that they've never seen the problems before, but they're able to apply the concepts that they've learned during their classroom time. Think of the training as the classroom time and the validation model as the test that I'm giving. Then what we're going to do is we're going to prepare the model. Once the model is validated and we're satisfied with the performance, we have to now do the final preparations. This could include things like additional tuning, finalizing hyperparameters, or it could be even a further validation of the model with additional tests. Once that's done, we're going to move on to things as loading the model into production. Now, typically what will happen is we're going to start serializing the model. Now, this is going to mean that we're going to take our trained, validated, and prepared model in a serialized form. What all this means is that it's converted into a format that can be saved to a file or a database, and we're going to make it easier to transport or deploy this way. It makes things a lot easier for the engineering team to then take this serialized model and then load it. And what we're doing when we load the model in the production environment is we're going to take that model file that's loaded into a database or some sort of disk space, and the application is then going to be using it to make predictions. Now, the front end is where the front end of the user interface of the application. It's the part of the system with which the user is going to interact. In the case of ChatGPT or DALL-E, this would be your little text prompt where you can type in a prompt and have it generate an image. That would be the front end. And then the user data is going to be the data input by the user through the front end. And this is where the data on which the predictions will be made in the production environment. And what's actually happening here, if you think about it, we're going to take our serialized, our loaded model, and we are going to then communicate to the front end, and the front end is going to communicate back. So it's going to send pictures and output to the user, and then the user is going to send prompts back through the front end to the serialized or loaded model. And then that's where we're going to have the prediction step. Now, typically what will happen here is that in the data creation step, we're going to have a simple example of a data science team will be able to do our model creation. But the engineering team or data engineering team will take that finished serialized model and then create a pipeline so that it can be used by the backend application all the way up to the front end application. Now, the next thing I want to talk about is known as variational autoencoders. So what variational autoencoders are, they deal with things such as encoding and decoding. So the idea of a VAE, they're just a type of generative models in deep learning. And what we're doing is we're just going to encode our data and then decode it. And this is going to enable us to generate new and realistic data. So the encoding step is the part of the input data that's passed through an encoder and neural network that learns to map the data to the lower dimension known as latent space. There's also things such as sampling that we'll talk about a little bit later, where there's an actual step that we need to do in latent space. These are the random vectors that are sampled to generate our new data points. And then there's things like decoders, where the sampled vectors from the latent space are passed onto the decoder neural network that reconstructs the original data. What we're trying to do here with this decoder step is to minimize the reconstruction error. By doing so, we're going to get new data. So there's a little bit of random sampling happening here in the encoding steps. The numbers here dictate the number of parameters that are in each layer of the variational autoencoder. You see we start out with a 28 by 28 image, for example, and then we pass that along to a layer with 500 parameters down to 250, and then we do some type of mathematical operation to determine the mean. We're in this latent space, and then we move on and we start building up the number of parameters from 250 to 500 back to the original 784 parameters in a 28 by 28 matrix. That gives us the original, it should give us as close as possible the image with the decoder step. And that's really what we're trying to do here with the variational autoencoders. Now, generative adversarial networks are a little bit different. They are trying to create new images. But the idea of GANs is to make two neural networks compete with each other. So what you'll notice is that you'll have the generator and the discriminator here. So the generator is going to try and generate images that are similar to the training data that we've given. And the discriminator is going to classify which is generated and which are the training images. So you can see here up at the top, I've got my generator and my real images, and I'll make samples out of my real images, which is my training data. And the generator will create a few images as well. I'll jumble them all up together in an array or a list or something, and I'll pass them along to the discriminator and ask it to identify which has been generated by the generator and which is training data, which is the real images. And what's going to happen here is that the discriminator is going to be used to classify between the two. It's going to try and determine the difference. And we're going to end up with two basic losses. So the generator loss and the discriminator loss. The discriminator loss is the passive data when it couldn't classify which is real and which is generated. And the generative loss is when the discriminator was able to classify which is real and which is generated. Now here's where it gets interesting. If the generator and the discriminator are basically competing against each other, what they're also doing is they're helping each other get better at their respective tasks. Here's how they do it. You get some random input vector that contains some random noise. You pass that along to the generator model. The generator model is going to create some generated fake example images, and they're going to mix them with the real examples, which is our training data. Once they're mixed together, we're going to pass them along to the discriminator model. Now, the discriminator model is going to do what's called binary classification. Now, the binary classification is going to tell us what's real and what's fake. Now, that's really all what I mean by binary classification. We're trying to classify things into two things, hence the term binary. So real or fake. Now, we know what's real and we know what's fake. And so when the discriminator is unable to tell the difference between what's real or fake, we help the discriminator, we update the discriminator model so that it gets better at telling the difference between the two. When you have what ends up happening as well is that when the discriminator is able to identify what's fake and it identifies it correctly, what it's going to tell the generator is that here's how we can update the model. You've made some mistakes. Here's how I could tell that the image that you generated, here's how I knew that it was fake. And it tells it a little bit on how it fixed that problem, on how it figured out that it was fake. And then the generator is going to take that criticism, yes, and it's going to take that feedback and update the parameters internally, and it's going to try and figure out the next generated fake example. So you'll notice is at first that the discriminator model is going to be really good to start. It's going to be really, really good at telling what's real and what's fake, because the generator model has a much harder task at first to generate new images. So it's going to look like a blob of pixels that don't look like anything. And the discriminator is going to quickly tell like what's real and what isn't very fast. So what we'll end up doing here is show you a little bit about how autoregressive models work. So if we look from the bottom of the slide up to the top, and what we'll notice here is that we've got these input characters. So this is an example of an autoregressive model that's going to generate images from random noise or learning vectors in what's known as variational autoencoders. So here what we're doing is more of like a language modeling that'll generate images by treating an image as a sequence of pixels. So I know I'm kind of using input characters here just to sort of show you, but I think this would work the same way with individual pixels in an image. So let's go with input characters here. You'll see that I have HELL, H-E-L-L, written on the bottom. And you'll notice that in my input layer, I'm immediately just I'm doing some type of analysis. So I take that input layer, those input characters, and I convert them into numbers. And so H would be 1, 0, 0, 0 vector, E would be 0, 1, 0, 0, and so on. And what we're doing here is we're passing them through weights, and we're comparing the weights. And we're doing this WXH weight, and we are passing those onto this hidden layer. And we're going to do as another parameter, and we're going to scale down those vectors from 4-dimensional vectors to 3. And you'll notice that there are some numbers there as well. And then there's another weights that we're going to pass on with WHH. And what we're doing here is we're taking each of these vectors, we're passing them into a function, and we're seeing, okay, there's some internal mathematical function that's happening at the hidden layer. And then we're passing those to the next layer. And what we end up getting at the very end are vectors as well, 4-dimensional vectors as the output layer, same as the input layer, but we can convert those to a letters. And so you can see that 1.0, 2.2, negative 3.0, and 4.1 is E, and so on. And that's how we can actually use autoregressive models. Now, the thing what I want to talk about here is known as diffusion models. And what this is, it's still a generative model, but it's a probabilistic generative model. And it makes use of noise injections. And what we do is use transformations to generate realistic images from random noise vectors. So you'll see that I've got adding the noise here, and I'm going to start off with a vector x0 and try and work backwards. So adding noise to the image is done by iterating the process of addition of noises. X0 is the real image. XT is the fully noised image. The same process of iteration goes for denoising an image. And you'll see that what I'm doing is I'm adding some noise. I get this XT, which is the fully noised image. And then what I'm going to do is remove the noise. So I start with my XT, which has all of this random noise layered on top of it. And I'm going to start removing that noise. And I'm going to be using the probabilistic model here to figure out, okay, what are my weights going to be so that I can reduce this noise so that I end up with the right X0. And this could have many different layers. There's many different steps that need to happen to start to remove the layers. And this is going to return back at least the original image. Now that is really the idea of diffusion models, being able to add our noise and then remove the noise to see exactly how well it's done. And then this is what we call a probabilistic generative model. And that's a little bit on how we can use AI training pipelines and how generative adversarial networks, variational autoencoders, autoregressive models, and diffusion models work at their core. In this video, we're going to discuss the real-world use cases for generative AI across various industries, from art to healthcare. Let's first get started with what generative AI is used for. So generative AI models, specifically generative adversarial networks, for example, can create new content, including images, videos, and music. And this is where the term generative comes in, is that we're actually generating new data. It actually can be used specifically for text-to-speech. These models can be used to convert text into speech by using human-like speech, making them useful for tasks such as creating voice assistants, reading out text, and many more, including translation. And not only can we use this for text-to-speech, but we can actually use this as well for writing. Generative AI models such as GPT-3, GPT-4, Gemini, they can assist us in writing tasks. These models can generate human-like text, and they make them helpful in drafting emails, writing articles, and really just any piece of writing at all. But they're also very powerful when it comes to product design. They can be used in product design and development to generate new design ideas and inspiration. These models can learn from existing designs and generate new ones, speeding up the design process and just making things cheaper at this stage of your product development. Another thing that we can do is automated custom software engineering. They can be used in software engineering to automate the creation of custom softwares. GPT-3 and 4, for example, can generate code based on natural language descriptions. And companies such as GitHub are using AI to assist developers in writing code. The tool that they use is called Copilot, and it uses GPT-3 to suggest code snippets to developers. There's also things like gaming solutions are possible to be generated with generative AI. They can be used to create new game elements such as characters, levels, more, textures, really anything. The models can learn from existing game elements and generate new ones, and we can add variety and novelty to the game. In fact, it's possible that when we create non-player characters to be able to communicate with the player, we're actually talking to a large language model as a role-playing device.
There's also healthcare solutions, right? So generative AI models can be used in healthcare to generate things like new drug models, molecules, predict design, disease progression, and plenty of more. But what's fascinating is that we can actually learn from existing medical data and generate new insights, speeding up the research and treatment process. But we can also have personalized experiences with healthcare and as well as any field at all. What's happening here is the model is learning from our user behavior and our own personal data to generate personalized content, recommendations, treatments for a disease that you're facing. It's really just about anything. And an example of this is Netflix, for example. They're already using AI to personalize user experiences. What we're doing is we can look at users' behaviors to generate personalized movie and TV show recommendations based on somebody's Netflix viewing history. Maybe they stopped watching a movie partway through. They'll have an idea of how engaged you were by watching the film. And there's also things like translating language, like I've mentioned earlier. For written material to appeal to all audiences, these tools, the AI generators, can help translate content into different languages in a very natural way. And we have something known as template creation. AI tools can help create emails or other templates, and some AI tools offer different types of ready-made templates for just about anything so that you can plug in your customized information. And it gets even further along. Like what we can do is we can use this as a writing assistant instead of a way to rely strictly on the technologies. And there's some ways that we can actually use it for research. Writers having issues organizing a topic or coming up with ideas can use this for inspiration, and it can help them get started on a project or a piece of writing. And we can also even proofread our current material. I use this all the time to proofread my emails and better structure my thoughts so that it's a little more coherent. The tool can highlight keywords and phrases that should be used, and can even assist with checking grammar and correcting spelling mistakes. Another powerful application that we can have is with entertainment. So in entertainment industry, AI image generators, just like in video games, can create realistic environments and characters for these kind of movies and TV shows and video games. And what's going to happen is it's going to save time and resources that would be used to manually create these elements. And so things like this would be a little cheaper to generate. And another one that we can use this for is marketing and advertising. Marketing and advertising, AI-generated images quickly produce campaign visuals. So instead of organizing a photo shoot for a new product, what marketers are doing is they can use AI to generate high-quality images that can be used in promotional materials. So it saves us time by just generating something with a text prompt rather than setting up a whole photo shoot. And it even branches into retail. In retail, generative AI is empowering brands to look at customized user experiences, design exclusive products, and even predict consumer preferences more accurately. And we can also assist with the supply chain problem. Supply chain problem is becoming a major issue. So in recent response to challenges in the supply chains, what generative AI is offering is looking at things like sales data. This technology will provide recommendations for things like inventory management. It can even assist in forecasting trends by analyzing historical data, consumer sentiment analysis, and even competitive information. So retailers can make informed decisions for ordering and manufacturing. And what's going to happen is that this optimization is going to aid in streamlining the supply chain and even improve our delivery efficiency all over the world. And so those are just some of the use cases that we can use generative AI across all of these several different industries. In this video, we're going to identify the popular AI frameworks and tools used for image generation. Let's first start with the basics of generative AI frameworks. So what does this include? Well, generative AI is not just a set of algorithms, but really what we are trying to do here is include things like our infrastructure for our systems. So when we're talking about generative AI, we're also thinking about the machines that we're using to do the training, as well in the complex mathematics and the computing power that'll come together to teach AI to predict the outcomes. In this case is going to be the infrastructure for our systems. But they also can have mathematical concepts underneath the hood that'll guide the AI models. And this is where it gets a very mathematical in a way. It won't be able to talk about it in this video, but know that underneath what's actually happening inside of these neural networks is really just advanced mathematics that the computer is very good at doing. And what we're doing with these generative AI frameworks is also be able to use them for training. So they manage our infrastructure for our systems. They will guide our AI models with their complex mathematics inside of them. And we use them to actually train our models. Now, generative AI frameworks are, there's a few different ones that are available. So one of them is known as Amazon Bedrock. Now, this is a transformative asset for generative AI, and it usually just offers sophisticated toolkits that are really good for decision making and a lot of the generative AI projects that we work with on a day-to-day basis. But really what it has is known as a model evaluation features. And so developers can assess, compare, and really select optimal foundational models to their specific needs. So it's a way that we can offer a human evaluation workflow for subjective metrics such as friendliness and style as well. And usually Amazon Bedrock is just a powerful ally in this model selection, and it usually makes a great system for decision making on what model to use, what foundational model to tune, and all sorts of things. So Microsoft Jarvis is what's actually leading the AI innovation. This provides generative AI engineers with an unmatched tool, and it just helps us with our daily work, similar to what Bedrock does. What Jarvis is very good with is collaborating with AI models like ChatGPT for unified and advanced results. And this is what's known as a task controller, meaning that we can maximize the potential of various open source large language models for things like images, videos, audio, and more. And we can even integrate with multimodal AI and expand the GPT-4 capabilities for things like text and image processing. Jarvis is a really powerful thing, but it requires at least 16 gigs of virtual RAM and around 300 gigs of storage space for various models. And what that means, we're going to have to be really going towards Azure's compute instances. And that's really what we're trying to do with Microsoft Jarvis. Another thing that is useful is known as LangChain. So LangChain is really a piece of software that's tailored for generative AI development. It really is very good at reshaping our day-to-day tasks, similar to Jarvis and Bedrock, but it's great at streamlining the application creation process, and it'll emphasize things like leveraging large language models to elevate the capabilities of general AI systems. Now, what at the core of LangChain is their agents, where it enables these agents enable large language models to make informed decisions, and it paves the way for creating dynamic chatbots, games, and a wide variety of spectrum of applications. Now let's go ahead and look at Llama Index. Now this is a pivotal tool in the arsenal of generative AI professionals. It's used a lot. This provides a seamless bridge between custom data and large language models such as GPT-4. This library is really good at enhancing the day-to-day work projects of anybody working in generative AI. But what is really useful with these tools is that it enables us to retrieve augmented generation, or RAG, combining LLM prowess with our custom data. And they operate with three main components. We have things for data connectors with Llama Index. For gathering, we have data indexes for even organizing the gathered data. And we have engines known as LLMs as our translators that takes this information and actually pipes it through to either fine-tune the system or create our model or deploy it. It's really a wide variety of tools that we can use with Llama Index. Mesh TensorFlow emerges as a revolutionary tool, and this is used in distributed neural network training strategies. This is called they use batch splitting, the prevailing data parallelism approach. But really what you're going to notice with batch splitting is it'll encounter limitations such as memory constraints for very large models. There's things like high latency and inefficiency at small batch sizes. But what Mesh TensorFlow is going to do is we're going to offer a language for specifying a broader class of distributed tensor computations. So this is going to help us do a more advanced training step or training loop with that goes beyond just the traditional parallelism. And users can split tensor dimensions across any dimensions, and we call these a multi-dimensional mesh processors, and it'll usher in a more generalized distribution strategy. So really what we're doing here is we're splitting the tensors that could be involved in our training data into multiple pieces. So it's not just regular parallel processing, but it's actually parallel processing optimized for work with tensors. Now, generative AI tools follow this thing known as GPT-4. So we've got the GPT-4 is the most recent version of OpenAI's, and some of the key features here is that GPT-4 has 100 trillion parameters. We have improved factual performance, even things like enhanced steerability. There's all sorts of things. It's very consistent and reliable time saver. It's cost effective and it even scales well, but it can provide the wrong answers and it can be extremely biased. So we need to still have some type of level of expertise where we'd have to verify what GPT-4 is actually outputting. DALL-E 2 is one of the most powerful generative AI tools for images. This is coming again from OpenAI, and it features the phased deployment based on learning. It has natural language inputs for producing images and art outputs, and users can enhance existing pictures using the in-painting tool, as well as just being able to iterate over the images that are created, giving the model feedback. This is really preferred for things like photorealism, and it prevents even harmful generations. But the cons here with this is that it's very expensive and it's less creative than humans. You have to give it exactly what you're looking for. ChatGPT is the most commonly used tool from OpenAI to date. This again has a natural language understanding, conversational context, all sorts of things that we expect from a large language model, but it's very good at providing just not more natural interactions and accurate responses. And it's also free, unlike the GPT-4 tool, but it's prone to errors and misuse. And remember that the tool cannot access data or current events after September 2021. GPT-4, on the other hand, can. So there's a slight difference between the two. We'll also have GitHub Copilot. Now, this is actually in partnership with GitHub and OpenAI. This is a code completion artificial intelligence tool. It's pretty wild that we have these around nowadays, but the intelligent code suggestions are offered by GitHub Copilot so that it's actually scraping information off of GitHub's open source repositories, and it's learning basically how to write code from already existing projects in many different languages. So it supports for multiple programming languages. It learns from our open source code, and it has auto completion and documentation and comments as well. And you can even integrate it directly with your IDE, such as VS Code. So you can actually download an extension that will get GitHub Copilot working with your VS Code or your IDE, and you can actually have code snippets pop up, which is fascinating. There are more generative AI tools that are available. Some of them are offered by Google, just OpenAI and Microsoft, but Bard is a chatbot and content generation tool. Currently, right now, it's being reframed as Gemini, but it's built on the Lambda transformer-based model. Well, I guess you no longer need a waitlist to use Bard. Now it should be available for everyone, and it's available through individual Google accounts. So it has ethical and transparent AI development approach, and it's pre-tested by numerous human testers. And some cons is that there's no conversation history features like ChatGPT, but it's unable to access things like that are involved in your Google account. StyleGAN is a great option when generative AI tools for images are discussed. This is a way for us to synthesize artificial pictures obscure from authentic photographs. We're using here is the GAN application to produce artificial face pictures, and it learns from a data set of notable faces. It's used to create things like virtual try-on experiences in fashion design industries. And there's also things such as AlphaCode. Now, AlphaCode, this is the transformer-based language model that's more complex than many existing language models. But what this is great is it provides training in a number of programming languages, including C#, Ruby, Scala, Java, JavaScript, the list goes on. It excels in Python and C++. So it has things like smart filtering after large-scale code generation. It can do transformer-based language models as well. The data sets and solutions are actually available on GitHub. And what it does is it programs capabilities in Python, C, and C++, and as well as several other languages. It generates code at an unprecedented scale. It does efficient critical thinking informed by experience, but its cons are its users dependent learning, and it can go wrong. So although it's great for helping you train in a number of programming languages, you still have to have some idea to verify what AlphaCode is telling you to do. Some more generative AI tools that are available here include things like Copy AI. This is one of the best artificial intelligence writing tools. And we have also a Cohere Generate. This is an AI company that helps businesses improve their operations by harnessing the power of AI. And it delivers custom content for things like emails, landing pages, product descriptions, and other needs. We have also Claude. This is a cutting edge AI assistant developed by Anthropic. This training AI systems to be helpful, fair, and safe, which is exactly what this tool is for. It's very good at processing huge amounts of text. It does natural conversations, can speak various common languages and programming languages, and it automates workflows. We also have Synthesia. This is a great AI video platform or tool for creating videos, not just images and text. So you can actually generate and broadcast videos of professional quality. There's content management, personalized onboarding, text analysis, all sorts of things. We also have ChatFlash. This is an AI generative tool that helps us to create content through a chat option. So ChatFlash is a great tool for this. We have SEO optimization, prompt templates, image generation. We also have Bardeen. This is an AI automation tool that enhances your productivity and saves time. This is OpenAI automation for your creative needs, and it operates even in your browser by using workflow automation. This is great for improving online content, and it has cost-effective and privacy-friendly features as well. Rephrase.ai is an AI generative tool that can produce videos just like Synthesia. It has capability to use digital avatars of real people even in the videos themselves. And we have SoundDraw. SoundDraw is similar to the text and images and videos that we have. Now we also have music generation. They are powered by AI that lets you create your own unique and royalty-free music, and you can use this music to enhance your projects or contents or for videos. And the great pros about this is that there's no copyright strikes in using this. You can actually generate music for whatever you need. So those are just some of the tools and fascinating things that are available for generative AI tools, such as things for sound generation, image generation, text generation, and really just video generation as well. In this video, I'm going to provide an overview for some key ethical considerations surrounding AI-generated images. Now, there's some ideas that I want to bring up here for generative AI ethical considerations, and two of them are dealing with bias and harmful content. So we understand that bias in really just about any type of generative AI is a bit of an issue. AI models, when fed with unrestricted data, they have the potential to amplify these biases that are present in the data set. So if our bias is present inside of our training data set, guess what's going to happen in the generated training set from an AI? It's going to also be biased. Bias is within the data, and it could be a societal bias, a cultural bias, or even just something inherent in historical records. They can manifest themselves within the model's output. So this has to be a major concern for us. Another issue that we need to be aware of is something known as harmful content. Now, what do I define as harmful content in generative AI? You might see these things in the news, but AI systems can create content automatically based on text prompts by humans. And really, any text prompt that we put in, and that could be something nefarious or something dangerous, such as creating some type of sexually explicit content with someone's face, that could actually be harmful content. So we need to have this kind of offensive language or harmful guidance sort of filtered out from the prompt so the generative AI will not be able to generate that harmful content. There's also some other ideas that I want to bring forward, and that's the idea of data privacy violations. Now we've got generative AI large language models, or LLMs. They're trained on data sets that sometimes include things like personally identifiable information or PII about individuals. And then we've got this kind of data privacy. And then we also have disclosure of sensitive information. So generative AI is democratizing AI capabilities, and it's making them more accessible. Because of this, what we have is a combination of democratization and accessibility. You could potentially lead to what's known a medical researcher inadvertently disclosing sensitive patient information, or engineer disclosing a piece of code to a large language model that should not be disclosed to a third party. And this consequences of unintended incidents like these could really breach patient or customer trust and carry legal ramifications themselves.
Now, there are some generative AI ethical considerations that we also need to be aware of that include security breaches. And we'll have the openness of learning models. They render them susceptible to what's known as malicious attacks. So what we're going to notice is that there's going to be exploits that are found that might manipulate or inject the data into a system. And you could have things leading to intentional misinterpretations or skewed outcomes. And this is actually pretty dangerous because these attacks could have far-reaching consequences. And you could have, something misleading an autonomous vehicle like your Tesla, for example, to manipulating financial predictions. They could really has major real-world implications for it. And then there's also the idea of deepfakes and misinformation. So generative AI's capacity to produce content that blurs the lines between reality and fabrication is really quite alarming. What you're noticing is going to happen is political figures, for example, you could make a video deepfake of a political figure saying something very dangerous, and that could actually fuel propaganda and detrimentally impact individuals, organizations, countries, really just anybody. And this is very dangerous. So it's something that we have to really have some way to filter those prompts and content from being generated with these AIs. It also has more legal implications dealing with copyrights. So you'll notice that popular generative AI tools, since they're trained on massive image and text databases from multiple sources, such as the internet itself, these tools will create images or generate lines of code that's very similar to what's already out there currently on the internet. And this data source could be unknown, but it could also be problematic for a bank handling financial transactions, or if you have something like a pharmaceutical company relying on a formula for a complex molecule in a drug. What you're noticing is that when you have these kind of legal exposures and copyrights, they could have a company's product could be based on another company's intellectual property. And then what happens? You have some type of concept of ownership and authorship becomes an issue. Who owns that? If we're violating a copyright by using somebody else's tools, how do we know? How do we handle that legally? So one of the main ethical issues surrounding AI-generated art is the question of who owns this art, who owns the rights to AI-generated artwork. And comes down to the artist who created the algorithm. It could be the machine learning model itself. And becomes a complex issue, legally speaking, where the algorithm has been trained on data sets that include copyrighted images. So maybe it's a portion or a mixture of who created those images themselves. Who knows? It's a little bit dangerous. So if you have the algorithm reproducing copyrighted content, who's responsible for the copyright infringement? Is it the person who wrote the prompt, the person who trained the model? Is it the model itself? It's all sorts of things that we have to try and work out. So what you'll notice in the next few years is that these questions are going to begin to be answered by our legislative arm, and this is going to help us figure out how to write laws around these kind of things. We also have generative AI ethical considerations that include things like regulatory and legal challenges. And these regulatory concerns, if you're dealing with enterprise companies, they're feeding extensive data sets into these AI tools, and this can pose significant legal challenges because you have such a high volume of data that often contains sensitive or personally identifiable information. Again, this is going to raise concerns about compliance with data privacy regulations such as HIPAA, for example. And without those clear guidelines governing these tools and the use of the data, companies face potential breaches of privacy laws and hefty legal ramifications as well. There's also data sources. So when we know that these data sources from our model itself, what you're going to notice is that generative AI systems consume tremendous volumes of data. And if you don't govern these properly, you don't have an idea of where those sources of data are coming from, you could be in violation of a law depending on where you're doing this and what service you're trying to offer in what region of the world. And then it actually goes on a little bit further than that. We have lack of explainability and interpretability is another issue. So many generative AI systems will group facts together probabilistically. And so this is going to really just help us with associating ideas and elements with one another. So that's really what it's for. But these details aren't really transparent, I guess, when it comes to using applications like ChatGPT. So because this data trustworthiness is usually into question, we don't really know exactly how these models are generating this kind of information. So it's hard for us to trust it. So when you're interrogating generative AI, analysts will use to arrive at casual explanations for outcomes, but machine learning models and generative AI search for correlations, not causality. And this is the idea of the problem, is that we need to be able to interpret and explain what the model is outputting. So it's not really, in the sense, replacing the engineer or the person. It's meant to supplement the person's knowledge. Simply, like, we wouldn't just Google everything and trust everything that we see on the internet. And this is the same idea, since we are training these models and images and large language models, whatever they might be, from training data on the internet. We really shouldn't be trusting what it's outputting. We also have the concept of plagiarism. So ethical concerns surrounding these generated images. Again, it deals with, who's owning this material. So obviously it's going to be mimicking already completed works of art. So what is considered plagiarism? What is not considered plagiarism? How far, obviously if it recreates an image online that's like exactly recreates it, then obviously that would be plagiarism. But then what degree? How far of a difference do we have to have before we start seeing plagiarism become a main concern and an issue? We also have workforce rules, and employee morale becomes an issue. So because AI is doing a lot more of the daily tasks that knowledge workers can do, including things like writing, coding, content creation, summarization, and analysis, you'll notice that worker displacement and replacement have been ongoing since these AI tools are being deployed. And this pace has just become accelerated, and it's going to either, we're at this point now where we're deploying these AI machines and we're thinking that, okay, we can actually cut costs by reducing people. And this is assuming that the AI can do a comparable job to what a human being can do. And there are flaws to these kind of general models. And so we have to be careful with how we train these models and how we start using them. Again, this is not so much to the point where it's showing up an existential threat of people's jobs, but it does affect employee morale when they're concerned with these workforce roles and how they're going to manage with generative AI. Are they feeling that they're going to be replaced? And this can actually change the entire culture of your organization if you're not careful. So an actual policy is going to have to be created, and this is just going to take some time before everyone sort of finds their footing with what these large language models and these image generators are going to be capable of doing. So that's a little bit of some of the ethical concerns and some of the, I guess, societal concerns with using these kind of image generators. In this video, I'm going to discuss AI's influence on photography, art, and other media. So with AI and creativity, there are some methods that have been previously unavailable that are now available. So the idea is that with this dawn of artificial intelligence, it's becoming more mainstream. We now have access to all of these tools that utilize generative adversarial networks, or GANs. We now have a concept of AI where these tools used to take human intelligence is now just being replaced by artificial intelligence. And so what you're noticing is that some artists are able to give complete control to the AI to actually generate their images or creativity or some type of video. And there are some artists who are using AI as part of the process to sort of help them be more creative. And these kind of things now are at the very core of these methodologies is the concept of this generative adversarial network that's generating these images. Now, the questions about intellectual property rights come to mind because, as we know with these kind of AI's tools, is that they're actually generating data or generating similar images that they've seen in their training data. And what this means is that we have to be careful with exactly who owns the generated image. Is it the company that created the AI? Is it the artist that actually created the images that are used in the training set? Or is it the person who created the prompt? It becomes an idea of who owns what at this stage, and legislation is still trying to catch up with this question. And we understand that there's certain value of creativity, but we need to ask ourselves, what is the value of the creativity now that a machine is able to do this kind of task? What is going to happen here? Should we be citing our sources for our creative tools? Now, one other question is we have to also ask ourselves, should the artist be transparent? An artist says, I created this piece of art, say that they used it with the help of AI tools or use an AI tool specifically to generate this image. It becomes, a bit of a gray area. We don't really know exactly what needs to happen or what it actually means for somebody to own a piece of property that's generated by AI. So then there's AI generation may also lack nuance, right? So there's bias in the AI technologies, right? So nuance and sensitivity are not really, a machine's strong suit because they're not really captured in the data sets that can result in, culturally insensitive and some type of harmful behavior. And that's something we need to try and pin down and get rid of. And that usually comes with trimming down our data set so it's more representative of something that's a little more culturally sensitive. And because of these harmful biases, they can also impact the art that we generate. And the art that reinforces harmful or discriminatory attitudes and representations can also lead to legal ramifications. There's also monetary value of the art. Now, since AI generated art could disrupt the existing marketplace of what art is actually being generated, because as we know, we're able now to just start to pump out creative pieces of art. What exactly we can do that in seconds. Like right now, we can just hop on to OpenAI's DALL-E platform and just generate a bunch of pieces of art in just seconds. What does that actually do to the marketplace of images that are currently out there as artwork? Will there be a sufficient demand to drive the pricing? Will it not? Who knows? If you think back to NFTs, that there's room at the table for new definitions of art, but if you think about them, their transactional value and emerging collector basis is really all it comes down to. So if you have new marketplace platforms that are designed exclusively for AI artists that have emerged, including the AI art shop, all sorts of things, this affects us, right? So with more and more AI artists creating works, questions of shifting tastes and trends have also been raised. And then what does it mean for collectors willing to pay high prices for the art that is created entirely by a machine? Or they prefer pieces that have been created by human artists? What has more value? And then there's art and democratization of art. AI could lead to more artists and perspectives, as we know, because we've lowered the barrier of entry for artists to actually create pieces of work. This actually leads to more variation, more content that's being generated, and you'll have different perspectives in our art. So maybe that in a turn could be a good thing. And then you could have things like hybrid art that could lead to new forms of multimedia. So when we're thinking of visual art and music, it could lead to new forms of multimedia art that challenge traditional distinctions between art forms and really just push what is the definition of art. So all sorts of interesting media and mediums could come out from this AI tool that we're using for art. And it comes down to this, right? So the role of AI in art curation. So as museum and galleries begin to incorporate AI tools, it may become easier to identify and showcase previously overlooked artists. You can have actually these tools are quite useful for when it helps with the impact of AI on art education. And as AI generated art becomes more prevalent, it may be necessary to incorporate new forms of artistic training into traditional art education programs. Everything really. A basic understanding of AI technology is just going to start being fundamental for artists should they wish to incorporate this technology into their practice, should they help them with creative ideas and solutions. And this is going to actually start being, teaching people machine learning algorithms, programming languages, and different data analysis. There's also other things I want to bring up here, and that, it's the idea is that the human touch is still necessary, right? AI can't replace photographers, for example. Unlike certain industries where AI has caused workforce displacement, if you think about photography as an art form, it remains uniquely positioned. If you think about how the human element intrinsic to the art of photography is really difficult to replicate in a machine. Photographers not only capture scenes, they infuse emotions, perspectives, stories into their work that's very difficult right now for a machine to sort of embed. And there are some forms of art that are just more susceptible to this kind of vulnerable areas, right? So they're more susceptible to this kind of issue. So as AI continues expansion into the realm of photography, you'll notice that certain domains will appear more capable of disruption than others. So if you think of the rise of AI generated portraits based on individuals, their pictures they have on their social media page, its utilization by brands to seamlessly integrate products into various lifestyle environments, that's going to be a very easily done with an image generator. But if we think about a photography system, somebody who, if we're thinking about having an AI powered automation tool for a photographer, it's much harder to do that because, again, it incorporates a lot of human emotion and this intrinsic art of photography. So that becomes a little tricky for us to sort of replicate, at least for now. Who knows where that will be in the next 10 years, though. So that's a little bit on how AI works with AI generated content and really what it can disrupt with AI art education and different art mediums. So I'm going to now describe the implications of AI-driven visual content for business and society. So as we know, the impact of generative AI in business is going to be pretty vast, right? They affect us not just with image generation, but really just any generative AI. It's going to help us with things like decision making. We can make better decisions by providing accurate and timely data analysis and actually create images surrounding that. We can use it for automation, for automating routine tasks, such as freeing up employees to focus on more creative and strategic work. And we can actually enhance what's known as the customer experience by personalizing interactions, providing more tailored recommendations and support or visualizations for a particular experience of a customer. And we can also, again, look at impact of generative AI on business when it comes to fraud prevention and detection. We can do things with process optimization. So not only am I able to aid in fraud detection and prevention by identifying patterns and anomalies in the data, but I can also optimize existing processes and identifies areas for efficiency improvements. And I can also increase competitiveness, identifying trends and opportunities that might otherwise be missed. The impact of generative AI on businesses will improve the accuracy and speed of predictive maintenance so that we can understand what's happening in manufacturing, other industries, and this is just going to enhance with reducing downtime and saving money. There's also things like new product development, where we can enable businesses to develop and deploy these new products more quickly and really just accelerate innovation and growth. But there's also things like the improved cybersecurity. So as these cybersecurity threats are changing, we can enhance our cybersecurity defense by detecting and responding to threats more quickly and effectively by having an automated response coming from a generative AI, watching this kind of firewall, for example. Now, generative AI is going to be very transformative. When we get to the concept of product design or any type of image design or brand design, whatever it might be, and the concept here I could think of is a logo design. If you think about a logo, it's a crucial element of any brand's visual identity. And these logo designs involved extensive brainstorming sessions, multiple iterations, significant investment in time. But now, with the advent of AI powered logo generators or image generators, for example, companies can now create professional logos effortlessly and cost effectively and in just seconds. You can hop on to using DALL-E, for example, and just ask it to generate whatever you'd like. And it really comes down to the prompt that you're using. And so this can also help us with chatbots and customer support in the more of a text. It's not just creating images for brands, but we can actually use generative AI in the sense that with text, with customer support. So AI-powered chatbots have just revolutionized customer support. You can provide instant responses to customer queries and enhancing brand credibility. These chatbots can handle a wide range of inquiries and even simulate human-like conversations. There's also generative AI that is transformative when it comes to things like content creation. So AI algorithms can analyze vast amounts of visual content to identify patterns, trends, and preferences. So it comes with that. But we can also, leverage things like, for example, Pinterest. It leverages AI to analyze user interactions and interests to recommend relative pictures or boards pictures and providing users with personalized content. Pinterest is using this go-to platform for this creativity tool. And then it even gets crazier with augmented reality. AI-driven AR technologies, they will open up new avenues for brands to engage with customers in immersive ways. And through these augmented reality applications, brands can usually use interactive experience that merge the physical and the digital worlds. And, if you think about and a great example of this is IKEA's app, where it uses augmented reality to actually show you a piece of furniture in your living room, where you plan to put it and what it would look like. So it helps customers to visualize furniture and decor in their homes before even making a purchase. There's some examples of industries being transformed by AI content generation. So we have the medical industry, where it is actually quite profound what's happening here. We are now providing person to person specialized, based on your medical history and your medical data, what treatments we can use that will leverage your current situation. And this is going to help us with troubleshooting this problem. And so you'll have key clinical health AI applications that could see this cost savings happen. We also have this thing known as the retail sector. The AI and retail are a match made in heaven when it comes to these kind of things, because it comes down to customer experience and satisfaction as the key metric. And what you'll see now is that AI can provide the ability of a personalization, not just with our medical history, but with our services and products that we're looking to purchase. And this retail sector is going to be revolutionized by AI as well. You'll have also another thing known as the banking sector. You're going to be primarily using artificial intelligence in this sector to help with fraud detection, where we can enhance customer experiences with online banking applications and basically identify any fraudulent transactions that could be happening inside of a bank. And accounting industry is another powerful thing that's there. So when we talk about the accounting industry, think about how complicated the tax codes are. They're very complex. There's a lot to do here. This accounting industry can look at your current tax situation, figure out what part of the tax code is relevant to you, and assist an accountant with creating proper returns or tax documents so that they can be filed. There's a construction industry as well. From planning to building, construction and engineering professionals are using artificial intelligence to add that extra element of accuracy and efficiency to the massive projects that are used. It helps things with monitoring, keeping track of equipment, including things like maintenance and construction errors, and as well as potential safety issues. You'll also see it being used in the mining industry as well. We can actually use artificial intelligence with a mining business, and we can identify what data processes making them 18 times faster to figure out, okay, how do we use an AI in terms of looking at mining data? How do we process these things faster? And so when you're considering applications of AI with the mining industry, what we're seeing now is a transition from people-focused operation to a process-oriented one. And this is where AI can improve the overall conditions for mine workers. It can increase accuracy, decrease environmental footprints. It can provide faster decision-making abilities in an environment where the error could signify to major repercussions, both legal, financial, and human losses, for example. So that's a little bit about how AI is being used in several different industries and how it can be disrupted to a few different methods in AI image generation, including things like medical history, retail, banking, accounting, construction, and mining. So in this course, we've examined to gain a comprehensive understanding of the fundamentals of AI-powered image generation. We did this by exploring AI image generation, pros and cons of generative AI, history of image generation, and use of AI in creative content generation. Generative AI models and methods, how it's used for generating content, and its components and use cases. Popular generative AI frameworks and tools and ethical considerations, and how AI influences art, implications, and the future of generative AI. In our next course, we'll move on to explore image generation frameworks and how they function.